In this video, we're going to discuss PowerVirtual RDMA support for native endpoints in vSphere 7 Update 1. PVRDMA native endpoint support enables greater compatibility between virtual machines and physical machines that require communication using RDMA protocols. At the end of this video, we'll meet the following learner objectives. We'll describe RDMA and PVRDMA. We'll describe PVRDMA support for native endpoints, and we'll explain how to enable native endpoint support. Remote Direct Memory Access, or RDMA, provides direct memory access from the memory of one host to the memory of another host. This operation does not involve the remote operating system and CPU. Network and host performance are boosted because of less latency and less CPU load with a greater bandwidth. In contrast, TCP/IP communications typically require copy operations which add to the latency and consume significant CPU and memory resources. With direct memory access, DMA, a device can access host memory directly without the intervention of the CPU. Remote Direct Memory Access, or DMA, is the ability of a device to access memory on a remote machine without interrupting the processing of the CPUs on that system. Some key advantages of RDMA are zero copy. Applications can copy data without involvement of the network software stack. Kernel bypass. The copy operation is carried out directly from the user space without kernel involvement. And no CPU involvement. The applications can access the remote memory without consuming any CPU time. This is an example of a copy operation without RDMA. So without RDMA, the copy operation between two servers must travel through multiple layers, starting from the application layer through the socket buffers, the transport protocol driver, and down onto the NIC hardware. Contrasting that with a copy operation with RDMA, the copy operation between the two servers is direct from the application buffer to the host channel adapter. With RDMA, the network adapter can transfer data directly to or from the application memory, eliminating the need to copy data between the application memory and the data buffers in the operating system. RDMA between virtual machines is called Paravirtualized RDMA, PVRDMA. A wide range of applications use RDMA for low latency and high throughput communication, such as high performance computing, databases, trading applications, and big data. PVRDMA has three transport modes that are selected automatically depending on the source and destination virtual machines. If both virtual machines reside on the same ESXi host, then a mem copy is performed between the two virtual machines, and the host channel adapter is not involved. If the two virtual machines reside on different ESXi hosts, and both those ESXi hosts have compatible host channel adapters, then a fast path RDMA communication mode will be selected. If one or more of the virtual machines resides on an ESXi host that does not have a compatible host channel adapter, then the RDMA transport mode used will be TCP RDMA. For more on paravirtualized RDMA, see Remote Direct Memory Access for Virtual Machines in the vSphere product documentation. In vSphere 7, ESXi supports communication between PVRDMA devices. In vSphere 7 Update 1, native endpoint support is introduced. This allows virtual machines that are PVRDMA capable to communicate with non-PVRDMA devices that are RDMA enabled, i.e. physical machines that are RDMA capable. Virtual machines that are communicating using native endpoint support are not supported for vMotion. The following is an example of a PVRDMA enabled virtual machine using native endpoint support to communicate using the RDMA protocols to a bare metal machine. The ESXi host that the virtual machine is running on must be enabled for RDMA namespace support. There are additional requirements for native endpoint support in vSphere 7 Update 1. The virtual machine must be running virtual machine hardware version 18. The ESXi host must have namespace support enabled. To enable native endpoint support, the VMX file of the virtual machine must be manually modified. The guest operating system must have kernel and user level support for RDMA namespaces. This is typically included with Linux kernel 5.5 and later, and user level support is provided by the RDMA core library. You may need to refer to your specific guest operating system documentation. To enable native endpoint support for a PVRDMA capable virtual machine, the virtual machine's VMX file must be manually modified. Once you add a PVRDMA device to the VM's virtual hardware, you should see a line in the VMX file with Ethernet and a number.virtualdev equals PVRDMA. The next line needs to be manually added to the VMX file, PVRDMA followed by the same number identified in the previous line, dot native endpoint support equals true. X refers to the ID of the PVRDMA Ethernet adapter of the virtual machine. At the end of this video, we've described RDMA and PVRDMA. We've described PVRDMA support for native endpoints and explained how to enable native endpoint support for PVRDMA enabled virtual machines. The key points: RDMA is the ability of a device to access the memory on a remote machine without interrupting the CPU. Virtual machine to virtual machine RDMA is referred to as PVRDMA. PVRDMA native endpoint support allows PVRDMA VMs to communicate with physical RDMA machines. A VM that uses PVRDMA native endpoint support cannot be migrated using vSphere vMotion. Virtual machine compatibility for ESXi 7 Update 1 or Virtual Machine Hardware version 18 is required when using PVRDMA native endpoint support. Thank you, and I hope you've enjoyed this video.